In this video, I'm going to solve the problems from chapter Rotational Equilibrium and Dynamics. First question. A wrench 0.5 meter long is applied to a nut with a force of 80 Newton. The force is exerted at an angle of 30 degree with respect to the line along the wrench. Find the following. So the first part of the question, find the torque applied to the nut. So what's the formula for the torque? The torque tau, which is equal to R cross F, which is RF sine theta. So this is the formula for the torque tau. So what is given in the question? The length of the wrench is given, which is nothing but the R value, which is 0.5 meter, and the force you apply to the wrench is exactly 80 Newton. 80 Newton. And the angle is mentioned as 30 degree. Now I am going to substitute all the values in this formula. So R is 0.5 multiplied by 80 multiplied by sine of 30 degree. So I have to calculate the value of tau. 0.5 multiplied by 80 multiplied by sine of 30. So the answer for the torque is 20 Newton meters. The unit for the torque is 20 Newton meters. So this is the answer for the first part. For the second part, find the maximum torque that can be applied to the nut. So what is the maximum torque? That means this angle should be 90 degree. So we have to consider the same R value and F value, but instead of this 30 degree, we have to consider 90 degree. So I'm going to rewrite this formula again. Torque tau, which is equal to RF sine theta. So R value is 0.5, F value is 80, and sine of 90 degree. Sine of 90 degree is 1. So multiply 0.5 with 80. So you'll get 40 Newton meter. So this is the answer for the second part. Clear? Second question. Calculate the net torque. That means you have to find both magnitude and direction on the beam shown in the figure about an axis through O. So here the axis, the point of rotation, we have to consider this part, okay, perpendicular to the page. So you have the beam, and the total length of the beam here they mentioned as 4 meter, and there are two forces. One is upward direction, which is 21.65 Newton, and the another force you are going to apply 10 Newton with respect to an angle of 20 degree. And the total length of the beam they mentioned as 4 meter. From the center of the beam to the axis of rotation, it's a half of the length, which is 2 meter. So now we have to find the net torque. So you have to apply the rule for the torque for this force as well as this force. Now this is our beam. So based on the beam, the angle for this 21.65 Newton is 90 degree, but for the 10 Newton force, the angle is mentioned as 20 degree. And generally, if you consider the torque moving in the clockwise direction, which has the negative value, the torque moving in counterclockwise direction has the positive value. So that means here the 10 Newton force will be in the clockwise direction, and then the torque applied to this 21.65 Newton is in the counterclockwise direction. So we have to find the net torque. So the net torque, again we have to deal with the rule RF sine theta. So for the first part of this 21.65 Newton, we have to consider the angle is 90. For the second part, we have to consider 20. So I'm going to write the rule. So the net torque for the first force. So what is that? RF sine theta and RF sine theta. Why I just wrote two times? Because we are going to use this rule for both forces. But we have to consider the sign. For this 21.65 Newton, it is moving in the counterclockwise direction, so it has the positive torque value. But this 10 Newton is in the clockwise direction, so it has negative value. And now, if you substitute the value, here the R value for the first force, 21.65 is exactly, so this is our R value, am I right? And here the angle is 90, so I am going to substitute the value in this formula. So if you substitute these values in the first part, the R value is exactly 2 multiplied by, and the force here is 21.65 multiplied by sine of 90 degree. So this is the part for the first, okay? So these are the values for the first part. Likewise, I have to apply the values for the second part. So here the sign is negative. So negative, but what is the R? So you have to consider this is the total length of the beam for this 10 Newton. So the R value here is 4. And then the force here is 10 Newton. So 4 multiplied by 10 multiplied by sine of 20 degree. Now, if you solve the first part, we are going to get 2 multiplied by 21.65 multiplied by sine of 90 degree gives the value of 43.3 minus, in the second part, 4 multiplied by 10 multiplied by sine of 20 degree, we got 13.68. So 43.3 minus 13.68 gives the value of 29.62. So what is the net torque based on the two forces? The net torque for this diagram for both forces 21.65 Newton and 10 Newton, we got 29.62. What's the unit? It's Newton meter. But we have to find the direction also, because here the answer for the net torque is the positive. So the torque here have the direction counterclockwise. What is the direction? Counterclockwise direction. If the answer you got negative, suppose if you got the answer as negative, so the direction is clockwise. Okay, so keep this information in your mind. If the torque is in the clockwise direction, it has the negative. If the torque's moving in the counterclockwise direction, it has the positive. Clear? Based on that, you have to give the answer for the direction. Now we have to solve the third question. What is given in the third questions? Read the questions very carefully. A window washer is standing on the scaffold supported by the vertical rope at each end. So you have to see the diagram. So that means this T1 and T2 is nothing but the tension. That means this side and this side we have the rope, which is represented. The tension created in the first rope is T1. The tension created in the second rope is T2. Clear? The scaffold weighs 200 newtons. That means the total weight of the scaffold is 200 Newton. So which is mentioned in this diagram here. And it is 3 meters long. So the total length of the scaffold is 3 meters long. So we have to find what is the tension in each rope when 700 Newton walks stand 1 meter from one end. That means if you see this diagram, from the end, the left hand side end of the T1, 1 meter, a person who is, that means the worker is standing. The worker is standing here. So what we are going to do, we are going to find what should be the tension for this both rope. So for that, first of all, we have to identify. And the most important thing, you have to fix the axis of rotation. So if you read this question, they said, consider the torque about the axis perpendicular to the page through the left end of the scaffold. So that means this side is the left side, this side is the right side. So what they said, the axis of rotation we have to consider from the left hand side. Clear? If you consider the axis of rotation from the right hand side, you will get the same answer. So better I will do for both. Okay. So first I am going to solve this question based on the axis of rotation from the left hand side, and the second time I'm inshallah I'm going to do the same thing for the second part for the right hand side axis of rotation. Okay. So let's start with the axis of rotation near to T1. Okay. First of all, I am going to identify how many forces acting in the upward direction, how many forces acting in the downward direction. So here T1 and T2 is in the upward direction. So T1 plus T2, which is equal to the downward forces. What are the downward forces? 700 Newton plus 200 Newton. So what's the total? T1 plus T2, which is equal to 900 Newton. So I'm going to take this equation as 1. Now I'm going to apply the torque effect for all these forces. So generally the downward force, the torque here is in the clockwise direction. The torque in the upward force is considered to be the counterclockwise direction. This is the rule. Okay. So now we already know the condition for the torque. If the torque is in the clockwise direction, it has the negative value. If the torque is in the counterclockwise directions, it have the positive value. Based on that, we are going to solve. So better I can solve here. So I will write the first equation one more time here. T1 plus T2, which is equal to 900 Newton. Now I'm going to consider this is our axis of rotation. That means the left hand side. Okay. So from the left hand side, there will be no torque, because whenever you consider the axis of rotation, you need the value of R. So, but if you consider this point is your axis of rotation, there is no R value. So the torque near to this T1 is 0. So what is the torque? The torque near to, because there is no R value. So that means we know the formula for the torque. What is the formula for the torque? Torque, which is equal to RF sine theta, but here the angle for each force is exactly 90 degree. So I have to consider torque tau, which is equal to RF. But if you consider this force T1, there is no R value. So the torque near to this T1 is 0. Clear? Okay. Now we can come for the second force. What is that? So this is the distance from this 700 Newton. Am I right? Because the person who is standing here, which has the 700 Newton weight, so I'm going to apply the torque based on this point. Okay. So what is the R value here? The R value here is exactly 1 meter. Am I right? So what I'm going to do first, I'm going to write this one. The torque near to T1 has no R value, so I have to put 0. That means T1 multiplied by 0 is 0. Okay. But for the second part, we have to consider this man, am I right, who is standing exactly 1 meter from the left hand side. So if you see this 700, it is moving in the clockwise direction. So it has the torque value of negative, and R value here is 1. So 1 multiplied by 700. Clear? And then I'm going to apply this formula for the second force, which is 100. And what is the distance from the left hand side to this 200? It's exactly half of the length. So the total length of the scaffold is 3 meter, but what is the half? It's exactly 1.5. So I have to apply this rule. Again, the torque in this 200 is negative. That means it is in the clockwise direction, which has the negative value. So negative of 1.5 multiplied by 200. Now we have one more torque, which is in the upward direction, which is in the counterclockwise direction, which has the positive value. Therefore, T2 multiplied by the total length. What is this? This is our R value for this T2. What is that? Which is exactly 3 meter. So T2 multiplied by 3, which is equal to 0. Now anything multiplied by 0 is 0. This will go on. But here we have minus 700 minus this 1.5 multiplied by 200, we got exactly 300. So minus 700 minus 300 Newton, which is exactly equal to because I'm going to move this part to the left hand side, by that it becomes negative. So negative of 3 T2, right? So left hand side we got minus 1000. Right hand side we got minus 3 multiplied by T2. I'm going to cancel this minus with this minus. Therefore, T2 which is equal to 1000 over 3, which gave 1000 divided by 3, we got 333.33. So what's the tension in the second row? The second row tension we got as 333.33 Newton. Clear? Now by using this T2 value, we are going to find what should be the tension in T1. Clear? So I'm going to substitute this T2 value in equation 1. What is our equation 1? Here we consider this is our equation 1. Am I right? So T1 plus T2, which is equal to 900. I'm going to substitute this T2 value here. Therefore, T1 plus 333.33, which is equal to 900 Newton. Therefore, T1, which is equal to 900 minus 333.33, we got 900 minus 333.33, we got the value as 566.67. So T1, which is exactly 566.67 Newton. Clear? So this is the answer for the third question. Clear? But what I told you initially, if you consider the axis of rotation either left hand side or right hand side, you will get the same answer. Better I will solve this question one more time by using the right hand side is our axis of rotation. Clear? You will get the same answer. Okay, let's try. I'm going to repeat the same question, but what is the axis of rotation? We got. I'm going to take the right hand side. What is the torque near to R T2? Because there is no R value, so torque near to T2 is exactly 0. There is no R value, but I'm going to write what are the upward force and what are the downward force. So T1 plus T2, which is exactly equal to 900. Am I right? Upward force, which is equal to downward force. But now I'm going to consider this is my axis of rotation. So near to T2 there is no R value, so I have to consider 0. So the T2 will not have any torque, but this torque is in the counterclockwise direction. These two have the clockwise direction, the clock near. Am I right? And here that person was standing. Am I right? And we have to apply one by one. So now I'm going to consider 200 Newton. So from these to these, we have the distance 1.5. So I'm going to apply the sign because here the sign for the torque is negative because it is in clockwise direction. So R value here is 1.5 multiplied by the force is 200. Clear? Likewise, I'm going to consider the 700 Newton based on the right hand side. So the length, the total length here is exactly, so you have see here the total length is 1.5 meter and left hand side we have 1 meter. So what is this length? So this length is exactly 0.5. So the total is 0.5 plus 1.5 is 2 meter. So again the sign is minus y because this 700 Newton is moving in the clockwise direction. But what is the R value here? 2 meter multiplied by 700. And again, I have to deal with this T1. From this T1 to this left hand side, what is the total length? 3 meter. And this torque is in the counterclockwise directions. We have to use positive. So positive T1 multiplied by 3, which is equal to 0. Now I have to simplify this equation. So anything multiplied by 0, 0. So T2 will go on. But here 1.5 multiplied by 200. So 1.5 multiplied by 200, we got 300. So minus 300 minus 2 multiplied by 700 is 1400. So 1400 plus 3T1, which is equal to 0. Now what I'm going to do, I'm going to move this to the right hand side, and here both are negative, so we can add, which is nothing but 1700. So 3T1, which is equal to, when this minus 1700 is going to the right hand side, it has the positive value, so 1700 will have the positive value. Therefore T1, which is equal to 1700 divided by 3. So what's the value? 1700 divided by 3, we got 566. So T1, here we got 566.67. 0.66 Newton. Clear? And now what I'm going to do, I'm going to take this T1, I'm going to substitute in this equation. So T1 plus T2, which is equal to 900. Once you substitute this T1 value here, you will get 566.66 Newton plus T2, which is equal to 900. Therefore, T2, which is equal to 900 minus 566.66, which gave the value of 333.33 Newton. So that means our both point of view, left hand side, if you take an axis of rotation, we got the same answer. If you consider the right hand side is your axis of rotation, again we got the same answer. Am I right? So it's not a matter if whether you can consider the left hand side as your axis of rotation or right hand side is your axis of rotation. Both will give you the same answer. Understand? Okay, now we have to solve the fourth question. What is given in the fourth question? A model airplane with mass 0.7 kilogram is tethered by a wire so that it flies in the circle 30 meter in radius. The aeroplane engine provides a net thrust of 0.8 Newton perpendicular to the tethering wire. Find first question. So this question has three subdivision. In the first part, we are going to find the torque. So before that, I'm going to write what is the mass of this plane, which is exactly 0.75 kilogram, and the circle of radius R is given, which is 30 meter, and the force you provided is the engine is providing 0.8 Newton. Now we are going to find the answer for the torque. So the torque is exactly RF sine theta, but here theta is exactly, they say, perpendicular. So what is the angle here? The angle here they mention indirectly as 90 degree. Am I right? So I'm going to substitute the value. So R value is 30 multiplied by 0.8 multiplied by sine of 90 degree, which gave the value of 1. So 30 multiplied by 0.8, we got 24 Newton meter. Clear? So the answer for the first question is 24 Newton meter. Now we have to find the answer for the second part. What is given in the second part? Find the angular acceleration of the airplane when it level flight. So we have to find the angular acceleration. For that, we have to write the relation between the torque and the angular acceleration. What is the relation? The torque tau, which is equal to I alpha, right? So from that, I'm going to rearrange this equation in terms of angular acceleration. Therefore, angular acceleration, which is equal to torque over I. So here torque tau, I'm going to use the answer from the first part. For the denominator part, moment of inertia, we already know I, which is equal to m r square. So how I can write this? Torque tau over mass multiplied by radius, that means r square. Clear? Now I'm going to substitute the value. Now I'm going to substitute the value here. The torque has 24 divided by the mass is 0.75 multiplied by 30 square. So the answer for the second part is 24 divided by 0.75 multiplied by 30 square. So we got 0.036 radian per second square. What's the unit for the angular acceleration? Radian per second square. Clear? Now third part, find the linear acceleration of the airplane tangent to its flight path. So as we already studied in the previous chapter, the tangential acceleration, which is exactly equal to R multiplied by angular acceleration. This is the relation connecting the linear acceleration with the angular acceleration, right? So I'm going to use the R value as 30 here, multiplied by alpha value. What is the alpha value? I'm going to take the answer from the second part, 0.036. So when you multiply this 30 with 0.36, you will get the linear acceleration. So 30 multiplied by 0.036, we got the value of 1.08. 1.08, and the unit is meter per second square. Clear? Fifth question. Three masses, each of masses has the value of 2 kilogram, are located at the corners of the triangle consisting of light rigid rods with coordinates as shown in the figure. So you have to see the diagram here. You have three masses M1, M2 and M3, and its respective coordinates are given here. So from the diagram we are going to find the answer. Clear? What is the moment of inertia of the system of the three masses when they rotate about this x-axis? That means the axis of rotation here we are going to consider as our x-axis. So when you rotate the x-axis, what will happen? All these three masses will be rotated based on this x-axis, right? So the axis of rotation here is x. So now we are going to apply this moment of inertia formula for each masses. As we already studied the rule, the moment of inertia formula is mr square, right? So I'm going to apply this rule for each mass. So therefore, the net moment of inertia I, which is equal to, I'm going to apply this formula for each mass. So m1 r1 square plus m2 r2 square plus m3 r3 square. So here r1 is nothing but the distance of the first masses with respect to the x-axis. What is the distance? The distance here exactly is 3. Am I right? So that means the distance of the first masses from the point of masses to the x-axis is exactly 3. Likewise, if you take the second mass, the distance to the x-axis is exactly -2 because the coordinates value we have. Am I right? Likewise, the distance of the third masses is exactly -2. So now I'm going to use this value. So each masses here have the same value 2. So 2 multiplied by 3 square plus 2 multiplied by -2 square plus 2 multiplied by -2 square. So now what you will get? 2 multiplied by 9 plus 2 multiplied by 4 plus 2 multiplied by 4, right? So here 9 multiplied by 2 is 18 plus 8 plus 8. So what's the answer? We got 18 plus 8 plus 8. So we got the value of 34, right? So 34 is the answer. So the moment of inertia for these three masses when it rotates about the x-axis. So when you consider the axis of rotation here is x. So based on this x-axis, we got the net moment of inertia formula for answer for these three masses is 34 kilogram meter square. Clear? So this is the answer for the fifth question. Now we have to answer sixth question. So what is given in the sixth question? Read carefully. A wheel of toy car has the moment of inertia. So the moment of inertia value is given here. So what's that value? I value here they mention as 0.35 kilogram meter square. The wheel rotates at a constant angular speed, making 50 revolutions in 7 seconds. So that means when the wheel is about to rotate, it will have the angular speed omega. Am I right? So the angular speed omega is not given, but the angular displacement is given, that theta. So theta, how many revolutions it have? 50 revolution it have. In time 5 seconds. So the time in this 5 seconds, how many revolutions it did? 50 revolutions. So 5 seconds. Now we are going to find what is the value of rotational kinetic energy of the wheel. As we studied the formula for the kinetic energy for the rotation, kinetic energy for the rotational body is half I omega square. So the moment of inertia value is already given in the question, but we need the angular speed. Am I right? So for that we have to find. So what I'm going to do, first I'm going to convert this revolution in terms of radian, and after that I'm going to find the value of this angular speed, and then I'm going to substitute the value in this formula. Okay, let's start. So I'm going to convert this 50 revolutions. So 50 revolutions in terms of radian. So 50 revolution, in one revolution, how many radians we have? 2 pi radian we have, right? So now I'm going to cancel this revolution with revolution. So I'm going to multiply this 50 with 2 pi. Therefore, my theta value is 50 multiplied by 2 multiplied by pi. So 50 multiplied by 2 multiplied by pi value. So I got the value as 314. Sorry, I think some problem. Theta is equal to 314.16 radian. And what's the time? Time 5 seconds. By using this theta and time, I can easily find the angular speed. Am I right? Because angular speed, which is equal to theta over time. So 314.16 divided by 5 seconds. What's the answer for this omega? 314.16 divided by 5. I got 62 point, not 5 seconds, sorry, I wrote it wrong. This is 7 seconds, right? Because they mentioned in the question 7 seconds. So I will modify here, just 7 seconds. Here also I have to modify as 7 seconds. So 314.16 by 7. I got the answer as 44.88. 44.88 radian per second. Now what I'm going to do, I'm going to take this omega value and I'm going to substitute this omega here. So we are going to find the value of the kinetic energy for the rotational wheel, am I right? So half multiplied by I, what is the value of I? Which is 0.35, and omega, just before we found the value of omega as 44.88 square. So now I have to work out 1 over 2 multiplied by 0.35 multiplied by 44.88 square. So what's the answer? So the kinetic energy value is 352.49, and the unit for the energy is joule. Clear? So this is the answer for the 6th question. Right? Seventh question. A football of mass m, which is equal to 0.3 kilogram, and it has the radius of 0.1 meter. So here I'm going to write the mass of the football. What is the mass of the football? The mass of the football they mention as 0.3 kilogram. And what is the radius? The radius of the football is exactly 0.1 meter, which is initially at rest at a height of 2 meters. That means you have to see the diagram. At a 2-meter height, the ball is at rest initially. So that means this is our initial condition. This is our final condition. So that means initial point and the final point. And what is the height? The height here they mention as 2 meter, right? And then the ball is rolls down in the inclined plane, in inclined surface as shown in the figure. What is the angular velocity omega of the football when it leaves the incline? That means we are going to find the value of omega. That means angular speed. Assume the football rolls without slipping and its moment of inertia is given. So the moment of inertia for the football they mention as 2 over 3 mr square. So this is the value for the moment of inertia for the football. Now we are going to find the value of this angular speed. For that I have to use the law of conservation of energy. Am I right? So here how many energies you have? Potential energy, kinetic energy, translational kinetic energy, as well as rotational kinetic energy, because the topic is related with the rotational. So what are the things you have? Potential energy initial plus kinetic energy initial for the translation motion plus kinetic energy rotation initial for the rotational, which is equal to the potential energy final plus kinetic energy final for the translation motion, and then kinetic energy final for the rotational motion. Clear? Now I am going to apply the rule. So when the ball is in certain height, it has the value of potential energy because the height is there. So mgh I'm going to write as final because this is the initial point, plus half mv square. And for the rotational kinetic energy, half I omega initial square, which is equal to mg h final plus half mv final square plus half I omega final square. Clear? Now, when the ball is at the height, you have the maximum potential energy. But when the ball comes down, what is the height? Because there is no height, so this term will gone, right? And also, when the ball is in the initial position, its speed, its linear speed as well as the angular speed is zero. So these two terms will gone. Am I right? Anything multiplied by zero, because the initial speed as well as the initial angular speed is zero. So these two terms will gone. So what are the remaining things we have? mghi, which is equal to half m. I'm going to convert this linear speed because we already studied v, which is equal to r omega. So I'm going to use this because I have to change everything in terms of angular speed, because we are going to find the value of angular speed. So for that, I'm going to apply this rule here. So what you will get, half m multiplied by r square. So better I can change everything small here. Okay, so this is small m, this is small r, because here I wrote everything small m and small r, so I changed everything here. So r square omega square plus half. What is the moment of inertia for the football? The moment of inertia for the football, they mention half mr square, right? So 2 over 3 mr square. So I'm going to substitute the value here for this I. So 2 over 3 multiplied by mr square multiplied by omega final square. Clear? Now I can cancel this mass both left hand side and the right hand side. Also I can cancel this 2 with 2. What is remaining? GH initial, which is equal to half r square omega f square. So I can take r square and omega f square as a common term. So r square omega f square multiplied by 1 over 2 plus 1 over 3, right? And I'm going to take LCM here. So therefore r square omega final square, inside the bracket I have to take LCM. So therefore this becomes 3 plus 2. The left hand side you have H and GI. So if you simplify further, what you will get? GHI, which is equal to r square omega f square multiplied by 5 over 6, right? Now we are going to find what is this omega value. Am I right? So I have to rearrange this equation again. Therefore, omega f square, which is equal to 6GHI over 5 r square. Therefore, omega f, which is equal to square root of 6 multiplied by the g value is 9.8 and the height they mention as 2 meter divided by 5 multiplied by, and the radius value is 0.1 square. So if you solve this, you will get square root of 6 multiplied by 9.8 multiplied by 2 divided by 5 multiplied by 0.1 square. I got the answer as 48.49. What's the answer here? 48.497. So I can write 48.50, and the unit for this omega is radian per second. Clear? So this is the answer for the 7th question. Understand? 8th question, it is the actually the 8th question is fill in the blanks, and the 9th question is match the following. So we are going to answer the fill in the blanks first. The cross product of force and the length of the position vector is known as, what's the answer? It's a torque, because we know the formula. What's the formula? Torque tau, which is equal to R cross F, right? Cross product. So R cross, so which is torque. So what's the answer for the first question? The cross product of the force and the length of the position vector is known as torque. The tendency of an object to resist angular motion is defined as moment of inertia. So this is the definition, right? So moment of inertia. The third, angular acceleration of a rotating object is dash proportional to the net torque. So what's the answer? As we already studied, the relation between the torque and the angular acceleration, torque tau, which is equal to I alpha, right? So that means the torque and this angular acceleration has the direct relation. Am I right? So what's the answer here? Is directly proportional to the net torque. Clear? So the angular acceleration is directly proportional to the torque. Understand? Okay, now we have to match the following. So mechanical equilibrium, if you want to make an equilibrium condition, the net force and the net torque should be equal to 0. Rotational kinetic energy, as we already studied, the rotational kinetic energy formula is half I omega square. So the answer for the second one is half I omega square. And then we have to answer this moment of inertia. We already studied the formula for moment of inertia. The formula for moment of inertia is I, which is equal to mr square, right? So the answer for the third question is this one. Clear? That's it. Thank you.